Hi, this is Nina Horn and my ENME489Y remote sensing homework 4 automatic lane detection via Python. And obviously credit due to Dr. Mitchell for our lectures for the basis of our pipeline. But just to go over the code and the detection method, we import our packages and then we load the videos. Right now I'm loading the test video 1, and then I'm just running a while loop for the whole rest of the code, just for while the video is opening or is open. We're looking at each frame, and then I snip the frame to like cut off the car that's in the image and a bit of the top as well. And then we mask the region of interest. So this I just did by playing around with the numbers to get it to the trapezoid that I wanted. And then we detect the lane line type. So just the yellow and white lower and upper limits, and then we grayscale and threshold. So threshold is what I found made the most difference between the test video 1 and test video 2, and so 120 was what seemed to work the best for both of them, just for those two videos. So I'm not sure how well this would work for a couple, other lighting conditions. But yeah, so that's our black and white image, and then we have our blurred image to make it easier to detect the edges using the canny function. And then in detecting the lines, we're using the Huff transform. So just doing that in this, and then once we have our rows and thetas, we're defining them for both the left and the right side so that we can differentiate between which line we're looking at. So I just looked at the outputs, just printed the lines and saw the values that it was outputting, and came up with the range for the left and for the right, and just used the append function to add them to our list for each one respectively. And then for our statistical analysis, I just did a basic median function and called them the midpoints. And then for those, I just defined point 1 and point 2 to make our line, and obviously connect those 2 points. And then we plot it on our snip. And then we have the wait key to exit the video if you need to. So let's run it for our test video 1. So we have the original image, snipped image, masked image, black and white, blurred, edge detection, and then our line plotting, obviously with the left line in blue and right line in green. And so as you can see, the big downfall of my current algorithm is that it flashes, especially when it's not this full straight line on the edge like we have on the right, but for the blue. So it would be nice if, and you also saw it struggle a bit on that section where it got a little light. But yeah, so some ideas for that, to fix that, would be to have it plot it for a couple seconds, and then once it sees a new one, then it will plot that one instead, so that you don't have multiple lines plotting. You still only have the one line plotting. But yeah, so that would be an idea to implement in the future to have it not flash so much. And let's see it on the test video 2. But yeah, so again, with the threshold of 120, it seemed to kind of work for both of them. And you can see it flashing again when it is on the dotted lines, and also when it gets like a little too light that everything looks white to it. So I would definitely want to like edit the like white and yellow bounds as well as the thresholding to try to get something a little nicer. Maybe use some other kind of like color things to detect. But yeah, it doesn't work quite as well on this video because we have like traffic cones and a lot of white light and stuff. And then some other ideas for improvement could be like doing a bit more intense statistical analysis than just the median, so that it like really knows a bit more what the line itself should be, based on all of the lines. And then another idea would be to like maybe adjust the image itself more when you're taking the video, like adjust the light so that it's more consistent between different lighting circumstances.